how you can what? You can just compute a very complicated nonlinear function in terms of sum of many polynomials. Okay, and because we know perfectly how to just integrate a polynomials. Okay, polynomials, for instance, what's polynomial? For instance, the a0 plus a1 x1, a1x plus a2 x squared, a3 x2, and so on. This is polynomial. If let's see the k degree polynomial, which we like to say that the function equals this. And we do know how to integrate this polynomial. However, you ask you how to do the integration of that. This is just the 0 to 2. No big deal. I don't think you can do it. I don't think there's a course for that. So it's difficult. However, if I just convert this, if I can write this in terms of sum of polynomial, I can rewrite this nonlinear function in terms of sum of polynomial. And we know perfectly how to integrate this. So that's the nice trick in scientific progress. And for Newton's method, that's because for instance, you want to, let's use the I want to see what's I want to find the root for this function, which is a difficult task for you to do. However, we want to find a root. Say if this is a root, it is if x has a root for f(x), then we imply f(x star) is 0. But you ask you to do this in the final exam, probably you may just go crazy because it's difficult, so difficult. However, this way to do it, if we can do it using the numerical method, say Newton method. And the importance of that is the last time we want to do in statistics or in lots of physics, physical physics, lots of disciplines, we need to maximize or optimize something. When you say optimize something, meaning you want to find a minimum or maximum of a function or objective function. Okay, you want to maximize something. You want to minimize something, right? What you need to do, you need to find the critical point, critical number. So taking first derivative, say equals 0. So the h is this form. We want to find x such that this function is 0. If that's difficult, then you probably don't know how to do. However, we can always use Newton's method. Okay, so let's see. That's about what we need to learn in chapter 10. Okay. Let's start with the sequences. And actually, I'll give you some overview about the Fibonacci number or Fibonacci sequence last time. Okay. But here, just we need to talk about what terms of sequences, and also divergence or convergence of sequences, and also limits of convergent sequences. When the sequence convergent, what's its limit? And if I give you a list of sequences, can you find a pattern? You should write out as a formula. You'll see. Okay, so a sequence is a function. It's a function whose domain is a set positive integers. So basically, we can write this way. So sequence would be a function from the initial number, which is positive integer, into R. So make it R. And this is a sequence. Okay. For instance, last time we talked about Fibonacci number. A1 is 1, A2 is 1, A3 will be sum of these two, will be 2, and A4 will be 2 plus 3 will be 3. 1, 1, 2, 3, then will be 2 plus 3 will be 5, and 3 plus 8. So F n is equal to 1, n equal to 1 or 2. Then f n is equal to f m minus 1 plus f n minus 2. N equal to 3, 2, 3, 4, 5. Okay. And there will be a sequence. So sequence is just a function. A function, however, domain will be a positive integer. That's how it meant. And here we say the n, a sub n is a term, okay? So we say the sequence, you can write this way, and sequence a sub n from 1 to infinity, you can write both ways. And a sub n, the nth term of the sequence. Okay. And for instance, n equal to, first one is n equal to 2n plus 1. I want to write out the first 4 terms. Okay, so a1 equal to 3, a2 equal to 5. A3 is equal to 7, A4 equal to 9. So B, Bn is equal to 3 over n plus 1. So B1 equal to 3 over 2. B2 equal to 1. B3 equal to 3/4. B4 equal to 3 over 5. Let me put this way, this is equal to 3 over 3, so it's equal to 1. That's kind of plain and simple. Limits of sequence. Your limit of sequence exists and the sequence converges. Otherwise, it diverges. Okay, let's find out when each of the limit of each sequence when you see when n goes in approaches infinity. By the way, the chapter 10 is a completely different chapter in the whole semester, in the 2 semesters of calculus. It's just so different, so actually, meaning even though you don't have a very concrete backgrounds in the previous calculus chapters or materials section, you probably still can get very good scores in this part. Anyway, this is totally up to you. An is equal to 3 plus but for this one, you do, for instance, the A1 equal to what? A1 equal to 2, because 3 plus minus 1 is 2. And A2 is 4. A3, S of 3 is 2. And A sub 4 equal to 4. So it's how it alternate. So limit and go to infinity, An does not exist. Okay. Because it's alternate. B. Oh, this actually you know it very well. So I'll just divide. You just divide the weighted for the numerator and denominator. We divide by n at the same time. So it will be 1 over n minus 2. This divided by n, this divided by n. You can think of it as I can do it by doing this. Okay. That's how I get this one. So it will be equal to 1 over n converges with 0. So it converges to 2. So the limit will be this. Minus 1/2. Okay. And C. Part C. But without doing anything, you do know that when n goes to infinity, right? When n gets bigger, 2 to the n gets bigger, and finally, at the end, you just see the approach to infinity. If this approach to infinity, and you plus 1, minus 1 doesn't make any difference. Okay. So we do the same thing. We just did we do the same thing here. Okay, we pretty much finished the section 10.1. Then let's move on to series and convergence. Okay, and for instance, for this one, that is a sequence. That's a sequence. But if I sum them up from first term to infinite term, then there will be this will be series. Sequence 是数列，series 是级数 ，OK， and for sequence we know how to, we just try to find if the an converge or diverge as n go to infinity. That's for sequence. For series, we also want to know if this converges or diverges. It is converges or diverges. How? It's a little bit like when we're doing the improper integral. For instance, okay, this is a geometric series. Okay, 几何级数 geometric series. Okay, and how to determine whether it converges or diverges? Also, okay, let's define the n partial sum. Sn is equal to summation k from 1 to n a sub k. Okay? For instance, for that would be for this series. This is a geometric series. Okay, for this series, okay, S sub n, which will be what? Which will be summation k from 1 to n and b2 to the k. That's the n partial sum. So be equal to 2 plus 2 squared plus 2 cubed 2 to the n. And this will be equal to basically is this kind of term. It's 1 minus ratio. And 1 minus the ratio to the n's power. And that's the first term. The first term. Okay? If for some reason you forgot about the formula for this either geometric series, then you can do this. For instance, s equal to 2 plus 2 squared plus 2 cubed plus 2 to the n power. And I just do it 2 multiplied s is equal to what? Is equal to 2 squared plus 2 cubed plus 2 to the n plus 2 to the n plus 1. Right? 2 multiplied 2 equal to 2 squared. 2 multiplied this 2 equal to 2 to the cube. And this be multiplied 2 be 2 to the n plus 1. And this subtract is 1, so you will get what? It will be 1 minus 2 multiplied s equal to what? Is 2. That's the first term. Then our A. First term. 2 and minus 2 to the n plus 1. So equal to, so 1 minus 2 multiply s equal to 2, 1 minus 2 to the n. And that's what? 2 is ratio. And that's the first term. N is because they are n terms. Okay? So we imply S is equal to 1, basically the formula 1 minus R, and the first term 1 minus Rn. You can see this will be equal to imply. So just compare that. So you forgot, you can always write the formula. So the n partial sum for geometric series will be 1 minus r is denominator, and this first term multiplied by 1 minus r to the n power. N is because they are n terms. Okay, so I cannot just switch it both. I switch this you can, because you can write it as depends on what you want to do. Because you can always write it. For instance, it's the A1, then you have Rn minus 1, R minus 1. These two are equivalent. That's why I write it there. Okay, so this will be equal to 2 to the n plus 1 minus 2. And this we do know is it diverges. We go to infinity. So this series, so let's find 2 to the n diverges. Because what? Because this as n equal to this, it go to infinity as n go to infinity. So this diverges. So this sorry, not sequence. So summation because it's because the series is equal to limit of n partial sum. That's fine. Okay. Let's see. There are something here. So in the section 0.2, there are 3 things. First of all, you want to determine whether or not a series diverges or converges. And there's a test we call n-term test for divergence. And the other one is we'll be talking about partial sum for geometric series. And the last one is just the determining of geometric series, whether it's converges or diverges. But basically, that's all the formula you need here. Okay. Okay, look at this one. Actually, 1/3 you can write as the series, actually geometric series, because it's 0.3333 is 0.3 plus 0.03 plus 0.003 plus 0.0003. So 3 over 2, 3 over 2 square, 3 over 2 the cube, and so on and so forth. So the summation n equal to from 1 to infinity, 3 over 10 to the n. And you look at this one, right? You see, weird, but we can do it the opposite order. So let's look at the summation. And from 1 to infinity, 3, and 10 to the n. So R here, what's the ratio here? R is 1/10. Okay, your first term is 3 over 10. Okay, so this is equal to 1 minus 3, 1 minus 10 over 3. I'm sorry, no, the 1 minus r, 1 minus 1 over 10, and the first one, 10 over 3 over 10, sorry, and 1 minus, let's see, wait. So Sn divided, wait. Sn is equal to summation k from 1 to 10 will be 3. So be 1 minus 1 over 10, then first term be 3 over 10, and then 1 minus 1 over 10 to the n.